I accidentally stumbled upon an Easter egg that reveals a hidden relationship between area, volume, and probability. I was exploring the probability of two bullets colliding if two people were shooting at each other, and I made a video about that, so you can see that for details if you want. But I had two models that seemed to contradict each other. One model is you take the width of the range and the height of the range, divide that up into individual squares, so we have a two-dimensional grid. In this case, let's just say it's 10 by 10, and say that the person downrange shoots at the person uprange. As that bullet travels from downrange to uprange, let's use what I call a traveling wall model. So there's a wall that follows that bullet, and that wall has a two-dimensional grid on it. So as that bullet's traveling up towards the shooter uprange, that bullet could be traveling from high to low or left to right or vice versa, and that bullet will be passing over one square after another on that two-dimensional grid. So when the person uprange sends a bullet downrange, they're not guessing where their opponent's bullet is at that particular instant that they pull the trigger. Instead, they're trying to guess where their opponent's bullet will be when both bullets meet up somewhere in the middle of the range. If the shooter uprange guesses the correct square, then the bullets will collide. If he guesses a different square, then the bullets will pass each other. So to get the probability of having two bullets collide, the formula is simply the cross-sectional area of the bullet divided by the cross-sectional area of the range. In this case, it'll be 1 over 10 squared, so it'll be a 1% chance of a hit. There is also a volume model that makes sense and seems contradictory. So now instead of having a traveling wall model where it's a two-dimensional grid that follows that bullet uprange, we're going to divide the whole range up into small cubes, each cube having the same volume as a bullet. So for those two bullets to collide, they must both occupy the same little cube at the same time. This volume model also adds an additional complexity because as that bullet is traveling down range, it's passing from one cube to the next. And in this case, let's say the range is 10 cubes long. That means that bullet is going to pass through 10 cubes to go from uprange to downrange. And every one of those cubes that bullet passes through adds an additional chance of hitting the opponent's bullet. So this is like getting multiple draws from a deck of cards. Well, with the area model here, you could have a deck of 100 unique cards, and you have one winning card on that whole deck, so you have a 1% probability of drawing that winning card. Here you have one winning card as well, but your deck is 10 times larger. But then to counter that, you get 10 draws. Because as that bullet travels from uprange to downrange, it has to pass through 10 cubes, each one of those cubes giving another opportunity to collide with the opponent's bullet. It could be more than 10 cubes if the person fires from up high and they point down low, so that bullet's traveling down at an angle, but let's just keep it as 10 cubes, the length of the range, to make it simple. So with multiple draws from the same deck, that means you use the multiple draw formula or the multiple attempt formula. I derived this equation on a separate video. The video was titled something like, does a second chance double your odds? But deriving this formula was actually really intuitive and really simple and kind of fun, so you can see that video if you're interested. So what you do is take your probability of losing, which is 999 out of 1,000, because there's 1,000 cubes and only one cube is the winner. But you get 10 draws from the deck of cards. Because the bullet passes through 10 little cubes, take 1 minus that, and you get 1% also. This works regardless of the dimensions of your square or your cube, as long as your cube has the same cross-sectional area as the square. So this is a cube, for example, that only goes 10 deep for the length of the range or the distance of the shooting range. But you could turn that 10 for the length of the shooting range, you could turn that into 100 or 1,000. You'll still get the same 1% probability when you use this formula. Or you could make your square, say, 3 by 3, and then the volume of your shooting range could be 3 by 3 by 100 or by 1,000. But as long as that cross-sectional area is the same, you'll have the same probability. I did try to prove this by setting this equation right here, 1 over x squared, equal to this equation right here. But because I had the exponents, then I had to take a log of one side, and I ended up with a complex log of the quantity of like x plus y, and both of those had exponents. So because of that complex logarithm, I wasn't able to prove this. I'll save that for the mathematicians that do this professionally. However, on my previous video where I was showing how to derive this equation for multiple draws, I did discover something that I'll call a conjecture or an observation, and I'll show that on the next page right now. When trying to guess the correct square on a two-dimensional grid, that was 1 out of 100 probability, because you had one correct little square on the grid out of 100 total squares. For the cube, instead of 1 out of 100, it was actually 1 out of 1,000, because the cube is 10 times 10 times 10. So this is the same thing as 1 out of 100 times 10, with 110 being in the denominator. But as I showed on my previous video, where a second attempt will double your probability of winning, that also means that if you make 10 attempts, it multiplies your probability times 10 of winning. So now instead of 1 out of 1,000, we have 10 draws or 10 separate attempts. That gives us 10 out of 1,000, which is 10 divided by the quantity 100 times 10. The 10s will cancel. We're right back to 1 out of 100, or 1%, which is what we got when we were looking at the probability of guessing the correct square on a two-dimensional grid. Also, when I say a second attempt will double your probability of winning, or 10 attempts will multiply your probability of winning times 10, that only works in low probability scenarios like this, where you only have 1 out of 1,000 chance of winning. So you can see my other video where I talked about the multiple draws for more details. So otherwise, that's it. That's the relationship between area, volume, and probability.